Hello everyone, it's Nate Zabwader from Engineering Symbiosis coming at you with a long overdue whiteboard lecture. This would be whiteboard lecture video 3 or 4, I believe. No, this would be 4. Whiteboard video lecture 4, excuse me. So, now that all of Ontario, Canada, and likely the world is on fire from runaway climate change or the disruption of the global carbon cycle, I feel like it's a good time to jump back into my theory work for Symbionics or Urban Ecological Niche Prosthetics, UENP, for those of you who haven't seen my previous whiteboard lectures and PowerPoint videos. Just to give you guys a quick update, I will no longer be using any AI for invention schematic generation, even though I did find it was helping me. Now that I have a whiteboard and I'm getting a little bit more used to trying to draw images on it, even though I'm poor at doing it. But I feel like it is a better alternative now that I'm more up to date on how much water usage and relative electrical grid allocation is used for AI data centers, and if it's obviously being used for some type of hyped up expanding surveillance corporate fascist state project. I don't want to contribute to that in any way, but I don't know if that's what the real reason they're hyping up all these AI data centers, but either way, it's severely ecologically destructive, and I don't want to contribute to that any more than I already have. Yeah, so this is my fourth whiteboard lecture video on symbiotic solar cycle capture. Alright, so I'm just going to flip it over. Alright, so this whiteboard lecture video is going to be on how my design theoretically captures more solar energy while doing a natural urban ecological function for purification of water as well. So if you look here, what looks like an almond shaped with, oh, that was too close. Just give me a moment here. What looks like an almond shape with a black line going through it and some water. So that, again, I'm not as good as illustrating as other people, but that's basically a weather balloon airbag that's usually made out of, if I understand correctly, usually made out of aluminum airbags or sometimes silicon airbags, excuse me. So a lot of that reflective material that you see in high altitude weather balloons, and I believe some high atmosphere space upper atmosphere space balloons that I think they used to carry certain weather detecting devices and even some satellites up into the atmosphere if they don't use a rocket the entire time. I could be wrong about that, but I do think they still deliver some satellites with high altitude space or high altitude upper atmosphere weather balloons. So basically, instead of using a flat surface like a solar panel that mostly, as I stated in my last whiteboard lecture, standard photovoltaic solar panels lose a lot of potential solar energy, simply because they're not designed to capture the amount of solar energy relative to the amount of thermal heat they absorb. So what I mean to say by that is they don't capture. So here the red arrows represent UV energy. The standard UV solar panels, and I wish I had enough room to draw a standard photovoltaic solar panel, but typically because they can only absorb the amount of solar radiation per surface area or per square inch or centimeter of the solar panels. So basically, the size. So a photovoltaic solar panel is limited to the amount of solar energy it can capture based on its size and width, or whatever the surface area. That's the term I was looking for. So a UV solar panel is typically constrained by the amount of surface area that it has, and it typically loses, again, like I said, most of that potential solar energy to outward radiated thermal heat, because when UV solar panels absorb too much thermal heat, they tend to break down. So I've designed my system, the Symbionic solar cycle capture system, to be able uh, uh, create more solar energy or capture more solar energy based on utilizing that very same solar thermal energy. So, I'll get to the schematic here. So in the middle of the main repurposed industrial symbiosis, upcycled or recycled high altitude weather balloon or solar solar wind solar wind bag or sail that might be damaged in the future. Let's say if they try to launch a solar sail craft and it's damaged, even at a manufacturing level. Let's say that it gets repurposed into this prototype. Excuse me. So like, basically, my idea is you take a recycled copper, gold, platinum, or any type of metal piping that could conduct electricity. Interestingly, I like the choice of silver and cadmium for the metal rods to go in the middle because they already when cesium and certain silver alloys are placed in sunlight, they already begin to start conducting electricity because of the if I have this correct, the ionic the ionic structure of the lattice makes it susceptible to having electrons become electrified in the presence of sunlight because of its metallic lattice structure, if I'm not mistaken. So basically, my idea is that you would repurpose this high altitude weather balloon or solar sail bag, and then you would fill it up with gray, as I've written here, black, gray, or brown water, and then you would fill it with sodium, like salt, or minerals, any type of rock minerals and sodium, and then you would using a small generator attached for it or access electricity of a given building. So the line here at the top represents it being attached to the side of a building facing the sun. Um, Using either a small generator for its own energies for its own energy source or access electricity not being used in a building, say from an idle room or something like that, could be used to power the Symbionics solar cycle capture device. So basically, my thinking is that you would use a generator or access electricity from the building to run a mid to low or even high electrical current through the metal or alloy pipe that's submerged in the gray, black, or brown water with sodium and or other types of minerals, and then by running a middle or higher end voltage current through it, you could essentially purify the water because the electrons would start to break up all the pollutants, as well as electrify the sodium and other types of minerals that you could put in along with the sodium. That would also start to break down some of the gray, black, or brown organic human waste or animal waste minerals. And then here, if you see, I'll try to zoom up as best I can. Oh, I said zoom in. Oh. Apparently, I'm still learning how to use my phone. Here you can see between the two containers, there is a pipe that is a air pressure control valve to. So like my thinking is once that the water is purified enough using different types of ecological or biohazard detection devices like pH monitors, regular toxicity, and water treatment devices. You could measure to see if the electrical current has purified the water enough, and then you could basically once the ecological monitors um, excuse me, it's been a while since I've had a whiteboard video lecture. Once the ecological monitors or devices read that the water is purified enough, it could be released into the water containment, where it would be further tested for any other extra pollutants. And the interesting thing about combining both solar energy and an electrical current with the water balloon or solar wind bag, if you will, is that with the combination of the middle range to higher voltage electrified metal pipe and captured solar energy, and also thermal energy in the form of heat in the form of solar energy, is that you could essentially use both the electrified current and the electrified current from the pipe and the heat from the solar energy to both break down the pollutants in the water, as well as the current, as I previously mentioned, and then it's released into the container where once it is tested to be purified enough to be released back into the surrounding soil of the building to help with urban environments soil restoration, as well as the urban ecology's soil restoration. So my thinking is that by using an upcycled or recycled industrial symbiosis based high altitude weather balloon or solar cycle airbag or solar wind bag, that you could essentially use it to capture more solar energy than a standard photovoltaic panel, due to the fact that, as you can see here from these outward black arrows facing outward and these downward facing black arrows, the band could expand and contract with the air valve that's also attached to control the water flow, to expand and contract to capture more sunlight throughout the day. So if the sun changes its altitude or its position during the day, say that the sun is further away from the Symbionic solar cycle capture device, it could contract with releasing of air and or water, and say if the sun is much closer earlier in the day, it could expand to capture more solar energy because of increased surface area. So that's one example of an advantage this design already has over standard photovoltaic solar panels, is that it can change the amount of surface area that it has through air and or water contraction. Excuse me. It can also have a dual purpose of capturing solar energy and conducting it back through the pipe, the metal pipe, and back into the building. So I didn't illustrate it here well enough because, again, I'm not good at drawing, but the pipe would the metal pipe that sticks in through the repurposed solar wind bag or upper atmosphere weather balloon would also be attached to the building, and whatever solar energy is collected could be channeled back through the other end of the pipe in the form of electricity, depending on how well the device is how well the my invention schematic for the Symbionic solar cycle capture goes experimentally. I'm not saying it would work 100% perfectly. It will have to go through several iterations, but the advantage of this design, as if you're familiar with my previous lectures, is that this actually takes care of 2 of the 5 most important biogeochemical cycles for a natural urban biogeochemical cycle, as I've stated previously, which are the solar cycle, the carbon cycle, the carbon cycle, the solar cycle, the hydrological cycle, the oxygen cycle, the soil cycle, the sediment cycle, and the nutrient cycle. So basically, with the Symbionic solar cycle capture device, you could basically augment it to purify. You could use it to capture and convert solar energy into electrical current, and you could also use it to purify water as well. And even if the recycled copper, aluminum, or metal alloy um, pipe inside of the weather balloon or solar sail bag that gets corroded over time because of water purification, uh, you could basically melt it down and turn it back into iron ore if it gets too corroded, and replace it with a different recycled copper, silver, gold, or alloy metal pipe, and keep using recycled metal piping from buildings or old internet infrastructure, etc. Because I'm a big fan of industrial symbiosis and reusing e-waste wherever possible. And the interesting thing I didn't mention in the beginning of my lecture is the other reason you would use water too is water is also good at absorbing solar energy. I'm sorry, you could tell it's been a while since I did a whiteboard video lecture. I'm stalling out on certain things that I meant to say. The other thing about using these Symbionic solar cycle capture device as a water purification system for buildings is that water is also very good at capturing heat in the form of solar energy. As we know from the warming of our oceans, the majority of global warming actually is coming from our oceans because that's how good water absorbs heat. So you can obtain more solar energy capture through both the water and the inflatable and deflatable high altitude weather balloon or solar sail balloon than you could a standard photovoltaic solar panel. So you're not only getting more converted solar energy than you would from a standard photovoltaic solar panel, you would also be getting purified water from the building's animal and or organic. Animal. You would also be getting purified water from purified gray, black, and brown water from animal and domestic human use from inside a building or building complex. So I'm going to zoom back out. Again, guys, I'm sorry for my ums and ahs. I don't really script my lecture videos because scripting them makes me more nervous and I fumble more. But that is essentially the Symbionic solar cycle capture. And as I stated in my previous lecture video about the standard concept of urban biogeochemical cycling or city-based biogeochemical cycling or architectural-based biogeochemical cycling, it literally utilizes both the solar cycle and the hydrologic. It is this design for the Symbionic solar cycle capture is literally augmented to work with both the solar cycle and the hydrological cycle to capture more solar energy and convert it into electricity for industrial use and human use, and purify the buildings or urban sites' water supply. So, yeah. Again, I'm not expert, and I'm not saying that it would 100% work. But if you're watching this whiteboard lecture video, I would love to hear your feedback. And because the place I live, Ontario, and all of Canada is literally on fire, and so is the rest of the world according to global maps about current tracking of wildfire and the super El Nino event and the 100-degree Celsius in the Arctic. If anybody's watching, please take my theory seriously. As you know, hopefully based on this lecture video, my theory of symbionics or urban ecological and use prosthetics, UENP, is not as abstract or highly theoretical as it seems. as I just showed you. This is a very practical usage of my theory that can already be implemented today experimentally with just the right quality of upcycled or recycled high altitude weather balloons and or metal piping, as well as solar sail material. Alright guys, if you guys were watching, that was my 4th lecture video on the Symbionic solar sail capture and water purification system. Alright guys, please leave a like and subscribe and share and tell everyone about Symbionics and Urban Ecological News Prosthetics, UENP, as the alternative to greenwashing corporate sustainability. Alright guys, have a great day.